All right, expectation and variance of a random error. This one's a bit of a doozy, but it's one of those things you can do step by step if you take good notes. So the issue here is we have a probability distribution, a few different values that x could take on, and then a probability associated with each of them. So do notice that it's not equally likely for x to equal each of these things. In fact, getting a 1 is going to happen almost half of the time, whereas getting a 0 is very unlikely. Do also notice that x could take on negative values here, and you might be thinking to yourself, oh, I thought it always had to be between 0 and 1. That's the probability of x. So notice all these probabilities, to be a valid probability, they have to be between 0 and 1. But the values that x takes on could be anything. It doesn't have to be whole numbers either. It could be pi or something like that. But we do have to have all the probabilities between 0 and 1, and to be a valid distribution, these numbers have to add up to 1, which they do in this case if you check them out. All right, so we need to come up with the expectation, the expected value, and the variance. So let's take a look here. I'm going to just grab all these numbers, open up Excel, maybe, whoops, make this just a little bigger, and then I'm going to paste those values. I just did a Control-C, Control-V on a Mac. I think that's a Command-C, Command-V. And I'm going to insert it. You don't need to do this, but just for clarity here, these are the different values of x, and this is the probability that x would equal x. And technically, again, I'm not picky about this kind of thing, but the little x just means the different values that the capital X could take on. All right, so expected value, that one's pretty straightforward. It's an average, and it's a weighted average. It's a weighted average of these values, and these are the weights. And to do that, we can just multiply each value of x times the chance of getting that value. By the way, we could do this on the other problems too, where it talks about games of chance or the insurance value. You could do this method for any of them. It's just this spreadsheet makes it a little easier when there's lots of values. So then I'm just going to grab this little right bar there, drag it down, and then I'm going to add these total up using equals sum. So equals lets Excel know its formula. Sum means adding, and then we have a parentheses, select them all, end parentheses, enter. So this here, this 0.6 is my expected value of x. In other words, that's the average x value. Now to kind of spot check, that average should be somewhere between your minimum and maximum value. In theory, kind of close to the middle, but that depends a little bit on where it is. So this one's 0.6, a little bit towards the positive numbers here because of that really strong chance of getting a 1. That's why it ended up there. Okay, now to get the variance, let me just pop this open real quickly here. So the formula I really like, I think is the easiest for variance of x, is the expected value of x squared, which we have not calculated yet. We don't know what the average x squared value is, minus the expected value of x, which is what we just calculated. And I guess we could do this a couple different ways. But we're gonna square that number that we just came up with. That's what's gonna get subtracted from this other thing. So do notice these are different. This is taking all the x squared values multiplied by the chance of getting each one, and then taking the average. So the average of the x squareds. This one's the average of x, and then once we have that average, squaring it. I know that's a bit confusing, but make good notes, see if you can go with it. So here are my x squared values. So each x squared value is just x times, and I'm just going to click that cell again so that it gets multiplied by itself. I could also put a caret and then a 2, which would also square it. Either way, you're taking -2 squared. drag that down. Notice now that they're all positive. That's something worth noticing. And this is why variance is always a non-negative number, by the way. And then we have the probability. So these are the different possibilities for x squared, and we want to know what's the chance of getting each one. Well, the chance of getting that 4 from the -2, it's 0.1. So we take 0.1 times that x squared value. Very similar to what we did here, except here we were taking the probability times the x itself. Over here, we're taking the probability times our x squared value. Okay, we get all of these. We can do a sum again, sum of this column right here. So this is going to be the expected value of the x squareds. In other words, this 2 right here, let me maybe highlight both of these numbers here. The 0.6 is my average value of x. The 2 is my average value of x squared. And you might think to yourself, well, can't I just take the average of x and square it? That would not give you the average value of x squared. Why? Well, for one, because those negatives are going to get knocked out once you do x squared. So you're going to expect to get a higher average already. And there's some other little details in there. So this is my average x squared value. This is my average x. If we go back to that formula, the variance is the expected x squared value. So in my case, that would be my 2 minus the average x, expected x squared. So that's 0.6 squared. I'm just going to double check, make sure I got those numbers memorized right there. 2 and 0.6. Yep. Okay. So this is going to be 2 minus 0.36, which is 1.64. And of course, you can do that in Excel or on a calculator, whatever works better for you. But that's going to be your variance of x. So our expected value of x was 0.6. And our variance of x was 1.64. Okay, and then we can, oh, it's way down there. We'll check those answers. And we do have a green light. All right, let me know if you have extra questions. I know that that's a lot again. Take good notes, step by step, practice it a couple times, and you'll get it.